Should be back live here. Hi. Let's check the Discord for updates. Oops, one DM that I got to answer on the side there. And I think we'll be reviewing Blaster. Let's see. Okay, so hold on. Okay, so this is Bet's feedback. Sorry, my contacts are a little screwy. Update on CodeBall, much better. Less pointless copy. Nice. That's fine. That usually happens. Step out of line. What? Found a bug. Tunnel through walls. Okay. What's this? Okay, Bet I think is just looking at feedback. Investigated high compute time. Compute observations the bottleneck. Any idea how to make this faster? Oh, let's go check Xander's M real quick. See. You have a perf test here. So let's run this. And we will do some profiling. Does this stream up? Oh yeah, there it is. Now it shows us up. Okay, so yeah, Xander, your env is not slow. Let's figure out what's up with his env in Python. Step. Num-ems 1024. This is correct. Ob size maybe? Let's check ob size. D type is numpy int 8. Num obs agent site range times 5. This is a perfectly reasonable obs. That's very high amp time. It's actually kind of bizarre. Hey, Xander. Do you have any idea what's weird with this thing? So if I build it in C with fast on, it's very good. So I'm not sure where the perf drop is coming from. Let me see. Python code, maybe? No, your step function looks fine. Hmm. It's definitely the env. That's like particularly weird. Not sure, just started investigating. Yeah. Report interval 1. Is it the logging, maybe? No, it wasn't the logging at all. Self.actions equal actions. The log. Is the agent site range not what I expect? Is that big? I don't think that should be too big. I mean, I can always do this. What's this do for us? Still 21%. That's crazy. Your M time should not be that slow. Let me make sure we didn't just break something in Puffer. That's like suspicious. Yeah, no, it's fine. Okay, so where could we possibly be dropping perf, huh? Is it possible the perf test is wrong? Let me see. M.num agents 4. Oh wait, max steps 300. I wonder if it's slower Maybe like your reset function is super slow or something. Let's... This includes compute ops, right? Yeah. Okay, so 2.3 million. Should be plenty fast. Really should be plenty fast. And minus start. Unless I'm missing something, this looks like a perfectly good perf test. Hmm. Added a call. Doesn't this do compute observations though? This already does compute observations, Xander. And that's normal, but if it's 2.3 million with compute observations, right? Because if you're doing, if you're profiling a step that already has compute observations in it, unless there's something wrong with the perf test, which would like, I suppose would make sense, because it's kind of crazy for there to be that much of a difference. Oh, whoops, yeah, you're right, yeah. So you're already doing that. Why is, hold on. You're only setting the action for the first agent here to rand %4. Right? $1.5 million. But that's still plenty fast. The random moves is still plenty fast. Do you have an LLM plugin or something? Yes, I have Super Maven. I highly suggest it. It's just a fast autocomplete. Like, I don't use it for full functions. I just use it to like autocomplete individual lines. It's a nice typing buff. Welcome back, Captain. Actually, why does nobody tell me when I do stupid shit like this? Like, why does nobody tell me when I clearly have my camera over my terminal? Just be like, hey, Joseph, you're being an idiot. Fix your term. Code EVS code. Yeah. This one has a NeoVim plugin, so I like it. And it's fast. And the devs are cool. num trash. Now let's try something like this. 20. Still 1.5 M. Remove all this garbage. There we go, that's cleaner. Step does reset as well, right? Yeah, Xander, it's not. The thing is, compute obs is going to be 90% of your time in an env like this. Like, think about it. The actual action of moving stuff around is free. Like, most of your compute is going to go into compute ops. But that's not the problem. If you're getting 1.5 million, right, then you should just be fine. You shouldn't have any perf issues at all. So I'm trying to figure out where they're coming from. You're not doing anything weird in here as far as I can see. Obs are reasonably sized. I didn't see any overhead in here. Hmm. What's all this error spam here? Okay, this is just like weird Python spam. Why is it compiling with O1 and O2? Okay. I think O2 takes precedence. We didn't change anything that would mess this up, right? That's Snake. Why are there two O Because Python and setup tools, basically Python is stupid is why. So with multiprocessing, we have 26%, but that's still obscene. It should be 0. Let me see what other params are on here. You just have to write a Python perf test. Sometimes we put these at the bottom of files so that we can do a pure Python perf test if things are being stupid. What in the hell? Okay, so according to this, you get 900,000 out of C. Does it need to be faster? Like, is it literally just that? That it needs to just be faster than this? Because most of our M's are faster than Hold on. What if I just, like, return? Okay, and then I do... Yeah, okay, so it is literally end speed. Yeah, that makes sense, I guess, when you add everything up. Okay, so let's just make it a little faster then. This bounce check. I still have to advance it. This bounce check is not helping. You'd like to amortize this bounce check. I'm trying to think how to do it with the way you have it set up. I mean, the one thing you could do would be to compute the indices. Hmm. Why is this so slow compared to like what I do in Snake? I guess you have all these different channels is the thing. Type. Well, there's some redundancy here. Oh. Let's reverse this to be if not is this the same thing? I don't know if this is correct. Let's see. Error. It didn't help very much. I don't like this bounce check is the thing. I'd have to profile this individually to see. Maybe we do have to flip the loops and do the math. Yeah. I think we gotta try at least. So we're gonna go to okay, so here's our perf test. I did make it a little faster. Oh, wait a second. Cell type. Hang on. Am I just not reading correctly? Oh. Yeah, that makes absolutely no sense at all. Is there a mem set here? There is not. Okay, so what we're gonna do is we'll get rid of this, I believe. Unindent. And then the one annoying thing is now we have to compute this observation index. I think it's worth it though. Use -1 for empty, I guess. Xander, is this ever possible? Cell type. I guess there's a carrying option here. I don't understand how these obs are structured at the moment. It's entity carrying. If it's carrying or not. I don't understand how that works. Because you have, or is it supposed to be the 5th channels for carrying? Added in 3rd loop to get rid of single carrying obs. Okay, so I don't think that was done correctly. If I did it or you did it, whatever, I don't remember, but let's see. So cell type is this entity type. So this is always 1 to 4. So we do equals. Why is it vision range -1? Oh no, it's not. 0 to 3, yeah. Agent sight range. Okay, something like this. I think it's something like this, Xander. Let me see if this actually compiles first. That's annoying. That's not faster. Hmm. It's got to be these computations, right? Let me see. Oh, I didn't recompile. Hold on. There we go. That's what we want. Mm-hmm. And then if all I do is if I just go to 2Ms, 2 workers, there you go, Xander. Let's see if it still learns. Welcome, YouTube folks. Currently just doing a little bit of perf optimization on Xander's cool environment. Possible my indexing math is wrong here. We will see if this thing, yeah, it looks not to be training. So probably my index math is wrong here. Let's figure that out. It's nice and fast though. So first of all, this is 4, not 5. Cell Y is agent to Y plus D. Let's see, so channel offset is agent site range. So this has got to be, yeah, this is wrong. So this is, let's see if that's right. So Xander, if you're still here, what I did is you were looping over each channel. You don't need to loop over the channels when it's just your one-hotting stuff, right? So you just loop over the cell tiles. You don't do all the redundant checks, and you just compute the index of the specific cell that needs to be one-hotted. I actually don't know why this is -1 either. You should just be able to set this to 0 the way this is. Okay, so still not training. Channel offset is... Oh, this has got to be... This is totally wrong. So you get your channel offset like that. Out of bounds versus inbounds. Oh, I see why you did that. Okay, sure. Then you have to always set... You do have to set this to 0 though. That's a little awkward. Well, I guess what we can do is trash bin. Yeah, I see what you did. Okay. It's just slightly annoying to compute the obs for is all. There's just some really obnoxious indexing math that we have to do here is all. Shouldn't. What did you change? The +1? I was recomputing the obs index. It's not +1, it's not contiguous in memory. Pretty sure. That was the permute thing that you had. It's channels first, not channels last. This is actually the thing that's making our lives hard here is PyTorch, believe it or not. Matching the way that PyTorch expects data. I don't know why the hell they do it this way. Also, it's very stupid to do it the way that they do it, but it's like an ingrained choice. If they use channels last format, which is also more efficient, then we would be able to compute data in that format. It's actually incredibly obnoxious here handling the padding. Xander, I honestly think it would be better to just add a wall. Like add like a wall type. Because having the pad the observations is just going to be slow. You know? Let me try this for now. Like, there's no way of doing it in contiguous memory like this. And this is super gross. Try this. Still no? Okay. What is total num mobs? Oh, it already has num agents in there? Okay. It's 3, okay. Wait, so it's plus 3. How's that work? Oh, because that's where the first entity is, duh, okay. Okay. No heap overflow. Maybe now it works. Welcome, YouTube folks. Hopefully the internet holds for today. I fix those damn drivers soon. Okay, cool. So that's the local speed. About fast. Okay, so that's substantially faster than before. Still not training? How bad could I have broken it? Anybody see indexing bugs? Agent index. It's 5 times the channel offset. Wait, where's grid size? Grid size. Where does this get set? Well, that's wrong right here. This is env. Yeah. Let's try this again. It doesn't build. What do you mean, no? Do I still have the indexing wrong? Let me see. So, 5 channels, agent index, 5 times channel offset, plus the Y, it's obs dim. Wait, agent site range is 5? Yeah. Plus obs X. Should be right. And then offset is type times channel offset, right? Set this to 1. Set this to carrying. As soon as we get this indexing right, your M will be fixed and will be a million steps per second train, as it should be. Welcome, YouTube folks. The M we're currently debugging for reference. You can play it on puffer.ai if you just hold shift down. It is this trash pickup env. You can watch these puffers collect and, collect and return all these different objects. And we have a way to make it way faster with some just like changes to the way in which we're computing observations in the C file. But there are a couple little bugs with it. Entity. Agent. What did we make the obs dim? Didn't we make it just the 11 by 11 or whatever now? Been watching back previous streams, slowly catching up. Very good. Hey, jump in the Discord, build some M's with us. When experimenting on top of your M's, how many architectural decisions and hyperparams are of importance? Action and ob space DMs could make a big difference. So the ones that are just completely unintuitive and you have to sweep, the most sensitive are learning rate, entropy, gamma, and JE lambda. Those are purely empirical, you just have to sweep them. There's some intuitions that you can develop around these, but they're usually wrong. Ob space schemes, generally, they're like, yes, there are decisions, but that can be learned. There's a method behind most of that work. And then there are several other things that matter that we don't have a handle on yet. That is going to be the subject of work starting in early 2025. Let me figure this out here. If anybody sees the indexing bug, feel free. I mean, this is just like silly. I mean, I really don't see it here because unless the observation dim is wrong, hold on. Num obs is 5. Yeah, this is correct here. Right? So it's obs dim 2 times agent site range plus 1 times obs dim. Let me just build this and see again. Put a breakpoint at like 204. Okay, so we have obs index of 10 and right here. Offset is 8. 129. Obs dim is 11, yes. Obs y is 0. 90x chan be 121. Agent index is still 0. Can you explain the last part of the offset? Yeah, so what you're doing here is each observation is this size. It's 5 channels and 11 by 11, so it's 5 by 11 by 11. So here you skip whatever the agent index is times 5 by 11 by 11, so you skip to the current agent. And then the goal is that you skip over rows. So this is to the first channel. So like your position in the first channel should be your y index in the observation times 11, and then plus obs x is your x offset into that 11 by 11 window. And then this bottom one here is skipping 4 channels so that you do the carrying. So offset's 14. This NT. Right. So that doesn't make sense, does it? So we're at 204. It's right here. Oh no, here it is. This is good. 135. This all looks reasonable. I guess I can observe, I can go look at these obs in Python to see what these look like. So I can't find any issue looking at the C. Okay, so this is all 0. Then trash is distributed around like this. This is possible. And then trash bin. I see multiple trash bins, so that should be wrong. And then agent 3. I see 4 agents, so that looks like that could be right. So the only thing that's wrong here is I see that there are 2 trash bins somehow. And then what about 4? Yeah, 4 is 0. So this is like almost reasonable. The only thing that's suspicious is the 2 trash bins. times 5. Type times channel offset. What is total num obs? Maybe that's wrong. No, that looks reasonable. So am I somehow wrong about the storage format or something? I shouldn't be. I definitely shouldn't be. No, because you did dy dx, so I'm correct. Is it plus 4 times channel offset? Yes, it should be. Cell X, cell Y. I'm trying to think what I haven't tried yet for this. And staring at it's not particularly productive. I'm like almost positive I'm just losing track of the index somehow. Agent index. And I used the agent index correctly. Is there plus 1 or something? No. check if the cell is within bounds. Yes. I mean, I have to be setting here. Found bin false. If found bin. Okay, and then we'll just do this entity type is bin. Okay, let's try this. I'm just gonna see if I can catch it double setting on no. Am I storing this in the wrong format? Because these loops are telling me that I'm not setting the bin twice per loop. Did you realize you don't actually pre-compute pathing in MOBA? Yeah, so it's cached instead of pre-computed, Captain. It should actually be cached. So right here, if not cached, and it should cache it otherwise. So the reason for that is that pre-computing, if you pre-compute and then load in 250 megs of data on the web, it doesn't like that. And also during training, you're adding at most 3 seconds total because it takes 3 seconds to pre-compute the whole map. So you're adding 3 total seconds over the whole course of training, assuming that it eventually has to do every single possible pre-computation. So it's a little bit smarter. We use the pre-compute function for like the little, there's like this little visual toy demo somewhere in there where you can like, scroll around with the mouse and see all of the pre-computed paths in real time. Do you see index logic bugs here? Because I don't see any index logic bugs here. I'm almost positive I'm doing the indexing in the right order though. Let me see. Oh wait, hold on. Is it? Just double check this message. Debate here. Let me just double check the original code. So I'm almost positive that I did the indexing order right, but you never know. Okay, so we go over. Yeah, this is the correct ordering as far as I can see. It's channel. Five by crop size by crop size. Is there anything else that I could have messed up in the process of doing this? Because those obs really look correct for me. Why are you multiplying by the type? Because I'm trying to skip that many channels. So the way it's laid out in memory, it's agents, then channels, then rows, then columns. So I'm trying to skip. So I've gone ahead by the tile offset here. And then I'm trying to skip ahead however many channels I need to one hot, just the specific channel that you need. I'm gonna have to get dinner soon, but I really want this thing to be fixed before then. Because I fixed your speed thing, right? I just have some index quirk. And this is now training at over 1,000,000 steps per second. There's just some little bug here. Wait, hold on. Obs Y times obs dim. Yeah, that's fine. Plus obs X. I think it's fine. And something's clearly wrong. It's 5 times channel offset. BFS instead of something like A star. It's a pre-compute anyways, Captain. Like, it doesn't matter. It's simpler and it adds 3 seconds total. That's across all the environments on a core as well, because it's cached across environment instances on the same core. So basically, it solved it in 3 seconds. Oh yeah, also the way we do it, you solve all paths with it. So A star, you cache less data at the same time, I believe. Because each call to BFS, I think it caches many values at the same time. Because you cache everything along the way anyways. So the only thing that A star lets you do is do, I guess, more calls that are less overhead each. For all paths, BFS is what you want. What the hell's wrong with this thing? Usually I don't get this hung up on index bugs. Like, what the heck? It is amateur hour here. Channel offset be obstim. Where? I don't think so. We want to jump ahead. It's a 4D tensor, right? So it's like 4096, or like, I guess 4 agents, 5, 11, 11. Oops. So you want to jump ahead by the type, which is the second index, times the channels, which is the number of elements in the last two. Don't you? I mean, I could just not be seeing something and doing something stupid, but... It's channel offset. That looks good to me. Like, what the heck? Let me try this. Why is it adding a /n? I don't know why it's printing the /n. Am I dumb? Am I stupid? Why is this not printing like normally? There we go. Ooh. Oh, that's funny. Huh? Credits. There we go. Yay! Okay, now we can actually see. Um, could try just printing out each value. See if it sequential. It doesn't sequentially increase is the thing. That's the annoying thing. It's not laid out nicely in memory. So 3 are the agents. 1, 2, 3, 4. Where's the trash bin? Did not see it anywhere. It's deterministic, right? Let's replace that before I forget it. But 1, 2, 3, 4. And there's the trash bin. Here's all the trash. These obs look fine. At least this version of the map looks fine, right? Now the question is, does it match? Entity type. I guess we do. Okay, so we just need one more /n. Okay, so here we go. Here is our map. This one is blank, this is good. And then this one, you can see this one matches. Yeah, this one matches first channel, and then second channel, there are no 2s. So this is empty, and then 3s. 1, 1. Yeah. So this matches exactly. So to me, this looks completely good. I have no idea why this doesn't work then. There are 5 channels, right? Where's the 2? It just, none of the agents can see it. It's not in view. I checked on a larger map. I made like the map obs larger and I saw like the 1, 2. So that's correct. I am zeroing yet, right? take another look at the obs and the policy. Okay, that's 0. 1. 22. Well, that doesn't make sense. There's not 22 trash, right? Yeah, there's not 22 trash. Am I writing over it somehow? I don't see how I would be writing over it. Yeah, that doesn't make any sense. 2 trash bins. The 4 agents is correct. It's not even the right total number of things, right? Not even the right total number of things. How do we do that? Especially when I literally just saw printed out, right? From C that we had the right total number of things. Ops looked reasonable. Like here's the big one. 1, 2, 3, 5, 6, 7, 8, 9, 12, 13, 14, 15, 20. Yeah, so these ops look good. And then I checked that they match here as well. It should be deterministic as well, though I guess I don't know if the seeding is the same. 1. You know, it's interesting to me that we have the first layer is 0, and the last layer is 0, which is what you would expect, but then they're just the wrong number of things within a specific layer. Can I do anything with that? Does that tell me anything? I don't think that tells me anything. Drive me nuts. That doesn't even make sense because they can't have that number of ones. $30. And the carrying is always 0. First channel is always 0. So yeah, somehow. Four agents, 20 trash, 1 bin. Should be 25. 25 at most. It really doesn't make sense to me. You might have to look at this, Xander. I'm having, I don't know here. I thought this looks correct, and all the prints look correct as well. And then it gets into Python wrong. Let's see, where's the char? I mean, I would think it would be like, it's like the wrong number of ones, though. It's not just the wrong shape. I don't even know how that's possible. And we literally check the obs as they're coming out. Like, what the hell else could it be? I'm like very confused. This was the most productive part I had right here was this debugging right here. Okay, so this is literally printing out these bytes like one by one. What if we do like this? So agent 0, we get 1, 2, 3, 4, 5, and then the original agent 1, there's the 2, 1, 4. Oh wait, now this doesn't match. Doesn't match for agent 2. Oh, because I'm still printing agent 1. Okay, agent 0, agent 1 has this 2 here. And then here's your 2. So your 3s. It's all correct. I'm gonna have to keep debugging this later because I can't figure out what the hell's wrong with this. That drives me absolutely insane. Like, I can see the data looks good in C, and then somehow it's wrong in Python. I know that you passed the correct num agents increment here. Num obs. What if I leave this? What if I leave these prints in? And if I do this. So here we have agent 3. You can see it's coming out here. Two, 1, 2. Oh, why? Hang on. Was that? No. Why is there this ghost 1? Hang on. Maybe it is wrong in, let's see. One. No, this is fine. Wait, is it? This line's wrong. right? This line is wrong. So these prints are weird. Oh no, this one is definitely wrong. So there is an indexing bug. How does that happen? Because it's like mostly right. Is agent 1 fully correct? No, it's not. Why wasn't I catching that in the pure C? Okay, so this one. This M doesn't seem to have it. Is it just a lucky seed? So this one can see all four. Oh, huh. It's correct in the C. But then when you run it through Python, it's wrong? Does that make any sense? Now look at this thing. Obsdim is 11. Yeah, completely messed up. If I check it meticulously in the C. Oh, you gotta be kidding me. Damn it, Xander, this one's on you. Let me see if this fixes it. I think this one's on you. That's freaking evil. Let me make sure it trains. Are you still here, Xander? We need better compile flags for our Python versions to prevent that from happening. That would get caught by compile flags. Let me make sure it works first. I'm pretty confident now, though, that I found it. Whoops. Yep. Okay. So Xander, the reason I've been debugging this for the past hour what is wrong with this right here? You tell me. Yeah. I'll give you the hint. It works in C. It doesn't work in Python. Your M now literally trains in 20 seconds, by the way. All right, you give up. Ready? Here's the change. I was using that in compute observations, and it was not initialized for Python. It was only in the C version. So now I can do M total num obs. Where is it? Oh, right there. I can build. Hold on. Okay, so I can, what is it? Demo and, okay, I can build, and now it'll work. It was writing garbage everywhere because total null was not initialized, so it was zeroing a random amount of memory. This now works with 0% env time. There you go. Let that be a lesson. Be careful what stuff you put in a init versus allocate. Allocate is just the extra stuff that is only needed in C. Really, that shouldn't have very much in it at all. There you go. I'm going to get rid of these prints. And then I'm going to push this. And I will allow you to train a new policy and do some stuff there. Yep. That's why I've been stuck for the last hour. Indexing was correct. That thing was off. I'm getting dinner. Hi, this is off topic, but how do I contribute to PufferLib? I've made an env nowhere near as complicated as current ocean envs, also nowhere as fast. Get around 300k SPS. You just jump in the Discord, discord.gg/puffer. Show us what you've built. Link us code, and I will do a live review of basically anything that you are willing to contribute. We do try to get the ocean M's that we take a fair bit faster than that. But I will check the I'll check the code and see, because usually I find in new contributors just a bunch of ways to make env code way faster. Let me merge this real quick. I've been fighting this bug for the last hour. Finally got it. At least now I don't have to go to bed after go to get dinner and go to bed angry. Yeah, but Xander, if you wanted to like really improve this thing, the other thing you could do is you could just make the obs a straight up one hot. You could just make the M's a straight up one hot, and then you'd be good. Yeah, I'll post the thing in the Discord. I'm gonna go grab some dinner. For all the folks watching this, if you're looking to get involved with this, it's just puffer.ai. We've got everything on the homepage. GitHub. Star it. It really helps us if you start the GitHub, actually. Discord right here, discord.gg/puffer. Join this. This is where literally everything happens. There's like no, you don't have to submit a resume. You show up and you start building stuff. It's that easy. And then there's also my X, where I post a whole bunch of stuff on reinforcement learning and the like. So if you're interested, you can follow me there as well. And this gives you notifications when I'm live. I'm live here, YouTube, Twitch. It's multi-streamed. That's pretty much everything. I am going to go get food. I will review Bet's Blastar Env tomorrow, I guess. I think he's PR'd it. And I will see you all around. Bye.